now we're live. Okay, so check it out. Here's what we know. Today is May. Oh, hallelujah! It's finally May. 5/2/22. Our objective is.
You put the date on your name.
I know, because I know my name. I do. So our objective is really to talk about log, rhythm, rules, and change of base. Yeah.
Happy Teacher Appreciation Week.
Well, thank you. Now let's keep moving forward because you guys are so distractible. Okay.
I just wanted to tell you.
You're awesome. So we say change of base. In our calculator, we have log base 10 and we have log base e. Those are the two main logs we use. Log base 10 because we count in base 10. That seems obvious. Log base 10 because we count in base 10. So when I take a look at my calculator and have just regular log button, plain old log, that's base 10. It's right by the 10 to the x, right? And log base e, and we use log base e because that's the number that things grow at in nature. The number e, we know the number e is about 2.71 blah 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 blah. Okay. Now the product rule. First of all, before we do anything, we know that logarithms are exponents. Okay, logs are exponent. I know that because I've got log of some base of some answer equals e, and what we've said is the e is the exponent, right? We've looked at that, right? We've gone from exponential form to log form, and we know that log of any base, that's a b, that's a lousy looking b, so you guys, it doesn't look like a b. Log of any base of an answer is always equal to the exponent. So logarithms are exponents. So if logarithms are exponents, they have to follow the exponent rules. They do. So if logarithms are exponents, then our first rule, called a product rule, starts out with this. If I have log of base b of some expression m times n, we can rewrite this in expanded form. Okay, so this is called expanded form. Log base b of m plus log base b of n. This is my expanded form, okay? When we multiply the bases, we add exponents. Okay, the quotient rule is just the same. If I have log of some base of m divided by n, we can put this in expanded form. We know that when we divide bases, we subtract their exponents. We'll go log of some base of an expression m, subtract log base b of n, okay? So, and I'll even highlight to make it easy for you. I'm going to make sure I highlight this. So times, plus, divide, subtract.
Can you stop making weird noises?
I have the hiccups game.
Anyway, okay, the power rule. So we know when we take an exponent to an exponent, we can have log base b of some expression m to some power, okay? To some power. So what you really have is an exponent. That's an exponent. An exponent to an exponent. That is an exponent. So logarithms are exponents. So we have some exponent to an exponent. So we multiply. So we bring the p down and multiply p, which is the exponent, times log base b of m. Okay, so we multiply exponents. We bring down the exponent. This is super handy. We're going to use this rule a lot. This rule we use a lot. Now, change of bases. If you have an old calculator and it doesn't have all the cool buttons in it, if you have some log of some base b of m, and this is not base 10, not base e, and you don't have a fancy calculator, you can still do it. You can still do it on your phone because you guys love your phones. You could just take and go log of m divided by log of b. Now, the invisible base is our calculator base, base 10, base 10. So we just use our calculator. Okay, an example. I'll do an example. I've got log base 3 of 25, okay? As an example. Well, it's got to be bigger than 2, so the answer is in between. It's not, I know that 3 to the third power is 27. 3 to the third power is 27. 3 to the second power is 9, so the answer is probably about 2.8, 2.9. I'm guessing. I'm just guessing, right? But I don't want to guess. I don't want to guess. You guys want to guess? No.
What
do we do? Just guess.
So you could just go and use your fancy dancy calculator. So if you have a fancy dancy calculator, get my fancy calculator out and go, okay, I can do this. I can go, okay, math. I can go to log base, there it is, log base 3 of 25 and about 2.9299. Okay, so guess and check. Or I could go rewrite this as log 25 divided by log 3. So if you don't have a fancy calculator, this will work. This will also work. So I can go, okay, I can go just log 25, close the parentheses, log 3, same answer, right?
What if you divide 25 by 3?
Totally different answer. Because then you're looking for 8 and a third, right? Okay. All right. Put the phone away, please. Phone away. Okay. Yeah, no, I meant them, not you. No, I know what you're doing, Sophia. I'm not yelling at you at all. No. Okay, so expand this. So this problem has an invisible times, another invisible times. So we're going to rewrite this as expanded log base 3 of 2 plus log base 3 of 2 plus log base 3 of x plus log base 3 of y to the 4th, okay? So invisible times, when I expand it, I just make those into pluses. That's all I do. Now there's one more thing I'm going to do. I have an exponent to an exponent. So I'm going to apply this rule right here. I'm going to bring the exponent down. So I'm going to bring this 4 down in front. And I'll rewrite this as log base 3 of 2 plus log base 3 of x plus exponent to an exponent. So I multiply, bring down the 4, bring down the exponent plus 4 times the log base 3 of y. Okay? You'll have a problem like that on your test. What do you think?
I don't like it.
Okay, well, where it says multiply, we just add. Where it says multiply, we add, and then if we have an exponent, we float the exponent down. Say it again. Where you have multiply, you add, and we have an exponent, you float the exponent down, okay? Okay, all right, number 2. So I have an invisible times, and I have a divide. So I'm going to rewrite this as ln, natural log, of 3 plus natural log of x squared, because there's an invisible times, right? Subtract natural log of y. Okay? So where I see times, I make it a plus. Where I see times, make it a plus. And where I see divide, I make it subtract. Okay? Now, there's one more thing. I have an exponent to an exponent. So I have an exponent. We float the exponent down. Okay? So I'm going to rewrite this as ln of 3 plus 2 ln of x minus ln of y. Okay? That's all we do. Now, example 3. Am I going too fast?
Wait,
Yeah, I'll wait for you.
why is it not L and wait?
So, are you talking about the base?
On the first one. Why isn't it? Oh wait, never mind. Sorry.
Got it? Good.
Yeah.
Okay. Everybody got it? Process?
Wait, explain everything again.
One more time. So, times
Slowly.
3x squared times, right? There's a plus between the two of them. Divide. There's a subtract between the two of them. If you have an exponent, you bring the exponent down. Up above, I did the same thing. Where I see a times, it's plus. Where I see a times, it's plus. And if I have an exponent, I bring the exponent down. So on example 3, we're just going to do the opposite. Just the opposite. So we'll start with the exponents. That is an exponent, but it got floated down. That's an exponent. Doesn't look like it, but it got floated down. That's an exponent, and that's an exponent. So we're going to bring the exponents back in. Just like we brought the exponent down, we're going to bring it back up. See, I brought the exponent down. Now we're going to bring it back in because we want to condense it. So we're going to rewrite this as log of x to the third plus log of y squared minus log z to the fifth. Okay, so I brought the exponents back in. They were exponents, they got floated down. Now I bring the exponents back in. Now, I see plus, so I'll bring them together as times. I see subtract, so I'll bring them together as divide. So I'll have a single log. I'll go log of, well, what do I have? Log of all of this. Well, I'm going to have an x cubed times a y squared. So I'm going to have an x cubed times a y squared divided by z5. Okay? We did just the opposite. Where it said plus, I brought it together as times. Where it says subtract, I brought it together as divide. Okay? Okay, you guys ready to turn the page? I'll wait for you. Yeah. Yeah, and Sophia, I was not yelling at you. I was yelling at Juan, who was flipping through photos. What? What? Yeah. Okay, turn the page. Here we go. Okay, now, example 4. So, if you have a nice calculator, it's really saying 3 to what power equals 12. Go back. Okay, so this is really saying 3 to what power equals 12. So the answer's got to be, stop talking, boys. Stop talking. So the answer's got to be 2 point something. Because it is 3 to some power equals 12. The answer's got to be 2 point something. Because 2 squared is 9. I'm guessing about 2.3 maybe. I don't know. So I could either use my fancy calculator, and I could do it. I can go find my math. I'm going to find my log button. There it is, log base. Enter log base 3 of 12. And I get an answer of about 2.26. Kind of what I thought. Approximately equal to about a 2.26, right? Or if I don't have that fancy button, like this calculator here, if I go to math, this calculator doesn't have it. It doesn't have it. So I could then change it to log 12 divided by log 3. The base is base 10, which is in my calculator, so I can do the exact same thing. I can go log 12, close the parentheses, divided by log 3, and I'll get the same answer. So either good technology, just use the button, good technology, or old technology, we can still get the same answer, okay? All right, now, example 5. Well, it's got to be a 3 point something. It's got to be approximately 3 point something, because I know 5 to the third power is 125, right? I know 5 to the third power is 125, but I don't want to guess and check. I don't want to guess and check. So I'm going to change it into log base 5 of 140 equals x. Okay, so I changed it from exponential form to log form, right? Now I could either use good technology, which I have, right? I use my good technology and I find the button in math. I can do that. And I find it there, log base 5 of 140, and I should get an answer of about 3.07, okay? Or if I don't have good technology, I'm left with old technology, I can just go log of 140 divided by log of 5, and I get the same answer. But I have to use old technology divided by log of 5. Okay? So you can do this stuff on your phone, but you're going to have to do it this way because your phone won't have log base. Decimals, I think, might. If you look at decimals might do it. But either way, you can get the answer. Okay, so homework for us. Page, homework. Yeah, wait. Page 157. I want you to do 1 through 19. Oh, it's easy.
On a Monday?
Yes. Oh, it's easy.
1 through 19?
Yeah, why not? That's easy. You'll get it done. You've got 25